Hi and Assalamualaikum everyone. We are from A4AS120419. Me and my friends would like to present about hydropower project.
But first, let's meet our team members. First, Nur Amira Husna binti Muhammad Nazri. Second, Nurin Hamimi binti Azahar. Third, Nur Anisa binti Elhemra. Fourth, Nurul Shazwani binti Abdul Rahim. Fifth, Amira Nafisa binti Azaman. And Nur Hafiza binti Gani. In this video, we will explain to you about the introduction, scientific instrumentation and application concepts, exploration application, examples of real-world implementations, potential benefits and challenges, future developments and innovations, and lastly, conclusion.
For the introduction part, I will explain a little basic information about hydropower.
Hydropower, or sometimes referred as hydroelectronic power, which draws energy from falling or flowing water to generate electricity. It depends on water-earth cycle, which entails the constant flow of the water between oceans, atmosphere and land to maintain a sustainable and renewable water supply. The principle of hydropower is converting the kinetic energy of moving water into mechanical energy using turbines that convert mechanical energy into electrical using generator. There are a few types of hydropower, which is run-of-river that use the river natural flow with less storage. It's less invasive and has a limited environmental impact. Secondly is pumped storage hydropower that consists of pumping water to a higher reservoir and releasing it to create energy from two water reservoirs at different elevations. Next is storage hydropower that include constructing a major dam and reservoir to hold water in order to produce energy when needed. Lastly, there are offshore hydropower that include tidal current of the power of wave to generate electricity from seawater.
Next part, I'm going to explain about scientific instrumentation and application concept. We have 6 crucial parts, which is the first one is flow meters. Flow meters is used to measure the rate of water flow into and out of the turbine. Accurate flow measurements are crucial for calculating the potential power generation and for monitoring the efficiency of the system. The second one is pressure sensor. Pressure sensor is used to measure the water pressure at various points in the system. Pressure data help in assessing the hydraulic condition and ensuring the structural integrity of the dam and associated infrastructure. Number 3 is tachometers. Tachometers is used to measure the rotational speed of the turbine. This data is essential for controlling the operation of the turbine and ensuring it operates within optimal speed range. Number 4 is voltage and current sensor. It is used to monitor the electrical output from the generators. Voltage and the current measurement are essential for managing the load on the power grid and for detecting any anomalies in the electrical system. Number 5 is temperature and sensor. Both water and equipment temperatures are monitored to ensure the system operates within safe thermal limits. Overheating can cause damage to mechanical and electrical components. And the last part is data acquisition system, or known as DAS. Is used to collect data from various sensors and instruments throughout the hydropower facilities. The data is used for real-time monitoring, control, and analysis to optimize the performance and safety of the hydropower plant. For the last part is application concept. The first one is electricity generation. The function is to convert kinetic and potential energy of water into electrical energy. The process is water flow through the turbines, causing them to spin, which drives generator to produce electricity. The second one is flood control. Function is to regulate water flow to prevent downstream flooding. The application, dams and reservoirs are managed to release water in controlled manner. The third part is irrigation support. The function is to provide a reliable water source for agricultural irrigation. The application is Water from reservoir is channeled to irrigation, canal and system. The last one is water supply. Function is to ensure a steady supply of water for domestic and industrial use. For the application is reservoir serve as water storage for municipal water system.
Let's moving on to application and technologies of hydropower. For their application, hydropower transforms the kinetic energy and potential energy of water into mechanical energy, which subsequently powers turbine linked to generator, thereby generating electricity. This method is the most prevalent, supplying a substantial portion of the world's electricity. Hydropower provides stable and low-cost electricity for energy-intensive industries such as aluminum smelting and chemical manufacturing, while pumped storage hydropower balances supply and demand by storing energy during low demand periods and releasing it during peak demand. Dams and reservoirs play a crucial role in reservoir management by regulating river flow, which helps mitigate flood risk during heavy rainfall or snowmelt periods. This careful regulation of water flow is essential for disaster prevention, as controlled water release can prevent sudden and destructive floods downstream, thereby protecting both lives and property. Dams are structures designed to block or redirect water flow, creating reservoir or height differentials to store water. There are various types of dams, including arc dams, gravity dams, and embankment dams. Reservoirs, on the other hand, are artificial lakes that store water for controlled release, which is essential for maintaining consistent power generation and managing water supply for various uses. Penstocks are large pipes or tunnels that transport water from the intake to the turbines. They are engineered to withstand high pressure as the water accelerates towards the turbines, ensuring efficient and safe operation. Impulse turbines are employed in high-head scenarios, with Pelton wheels being a prevalent example, where the force of water jets striking the blades drives rotation. On the other hand, reaction turbines are suited for low-head applications. These include Francis turbines, commonly used in medium-head settings, and Kaplan turbines, utilized in low-head settings, featuring adjustable blades and enhanced efficiency. The primary function of both turbines types is to convert the kinetic and potential energy of water to mechanical energy through the rotation of turbine blades. Generators are linked to the turbine through a shaft, facilitating the conversion of mechanical energy derived from the turbine into electrical energy via electromagnetic induction. Transformers are then employed to amplify the voltage of the electricity produced by the plant, ensuring efficient transmission over long distances.
I will present 4 examples of hydropower projects that have been successfully implemented in Malaysia. First and foremost is the Bakun project. The location was in Sarawak on the Batang Balun of the Rejang River. The project consists of hydroelectric power plant with a capacity of 2,400 megawatt and a power transmission line that is linked to an existing transmission network in Sarawak. The Bakun Hydroelectric Power Plant (HEP), which began operation in 2011, has been supplying a consistent energy output of 1,771 megawatt to correspond with the need of the power system. Currently, the Bakun Reservoir is the largest and most voluminous reservoir or lake in Malaysia. It plays a crucial role in supporting the Sarawak Corridor of Renewable Energy (SCORE) initiative, namely in the Samalaju Industry Park, where energy-intensive heavy industry are located. The Bakun HEP is a dam constructed using a concrete face rock fill method, or CFRD. Furthermore, the second example is the Murum Hydroelectric Project. The location was in Sarawak along the Murum River. It had a capacity of 944 megawatt. The Murum HEP features the highest tip spillway in the world, showcasing its revolutionary design. Sarawak Energy's Murumeshipi is their second hydroelectric plant. The main objective of the ecological power plant is to maintaining a functioning ecosystem in the upper course of the Murum River. Sarawak Energy technically owned both projects. In addition, there was the Sultan Mahmud Kenyir Hydropower Project. In honor of the Sultan Terengganu, the Sultan Mahmud Hydroelectric Power Station was named. It was located in Kuala Terengganu, Terengganu, with its active capacity to hold 13.6 billion cubic meter of water. The lake can generate 400 megawatt of power for all of Malaysia, generated annual of 1,600 gigawatt per hour of electricity. Prior to its complete commissioning in December 2015, TNB hydroelectric power was boosted by the 250 megawatts combined capacity of the Hulu Terengganu hydroelectric project. Ultimately, the last example was Ulu Jelai hydropower project. It was located in Cameron Highland, Pahang. It was carefully considered throughout the planning process. The Ulu Jelai hydroelectric project utilizes the flow from two nearby river catchments that are channeled into the main reservoir. The project main dam is situated on the Betam River. The underground powerhouse is located 350 meters below the reservoir, which provide the necessary head difference of power generation. A total installed capacity of 382 megawatt and is estimated to generate average 374 gigawatt per hour of electricity annually. At present, TNB's hydroelectric power plants have an installed capacity of 2,161 megawatt. By switching out traditional power generators powered by coal and other fossil fuel during peak hour, the project will lower annual carbon dioxide equivalent emissions by about 250,000 metric tons. Malaysia has experienced outstanding change in just few decades, and the 326 gigawatt per hour of energy produced each year enable the country's power supply infrastructure cope with the rise in demand during peak hour. The electrical grid will be more reliable and less susceptible to frequency variation thanks to the hydropower facility. In essence, TNB owns both projects.
Now I will explain about the potential benefits and challenges of hydropower. First, let's talk about benefits of hydropower. Hydropower is a renewable energy source as it utilizes the energy of flowing water, which is continuously replenished by rainfall. Next, reliable. Unlike some other renewable energy sources such as wind and solar, hydropower generation is relatively consistent and predictable. It can provide stable source of electricity, particularly in regions with reliable water flows. Moreover, hydropower is cost efficient. Once the hydropower is constructed, it has low operating and maintenance costs compared to other forms of energy production. Lastly, multi-uses. Many hydropower provide additional benefits such as secure drinking for communities and flood control. Now, let's shift our focus to the challenges that come with hydropower. Firstly, hydropower may cause environment impact that can disrupt ecosystem. It will leading to habitat loss and altered water flow pattern. Secondly, limited development potential. Suitable sites with adequate water flow are limited and changes in climate pattern. Thirdly, long development time of hydropower. This is because hydropower project can take many years to build from planning through to construction and commission. It can delay the time when they begin to deliver benefit. Last but not least, high initial costs. This is because the constructing a hydropower plant is substantial. These include costs for feasibility studies, engineering, construction, and infrastructure development.
Now, I will explain about future developments and innovations of hydropower. These are some potential future developments in hydropower. First, advanced turbine technology. Ongoing advancements in turbine design, including innovations in materials, blade shape, and efficiency, could significantly improve the performance of hydropower project. Next, maximizing hydro potential. The remaining hydro potential should be developed to the maximum possible extent, provided it is implemented in a technically, economically, and socially acceptable way. Third, small-scale hydropower. The development of small-scale hydropower projects, such as run-of-the-river installations and micro-hydro systems, can provide clean energy solutions for remote or rural areas, contributing to decentralization of power generation. And lastly, pumped storage hydropower. The expansion of pumped storage hydropower facilities, which store energy by pumping water uphill during times of low demand and releasing it downhill to generate electricity when demand is high, could help stabilize electrical grids and integrate more intermittent renewable energy sources like wind and solar. Next, the innovations in hydropower. First, underwater turbines. These turbines could be placed in ocean currents or rivers, utilizing the constant flow of water to generate electricity. They could be particularly useful in areas with strong tidal flows. Next, smart grid integration. Integration with smart grid technology could enable more efficient distribution of hydropower generated electricity. This could involve real-time monitoring and adjustment of generation levels based on demand, as well as better coordination with other renewable energy sources. Third, fish-friendly turbines. Innovations in turbine design that minimize harm to aquatic life, particularly fish, could help mitigate some of the ecological impacts associated with traditional hydropower installations. And lastly, floating solar hydro hybrid systems. Integration of floating solar panels with hydropower installations, leveraging the complementary nature of solar and hydropower generation. These hybrid systems could maximize energy generation potential while utilizing existing water infrastructure.
As a renewable energy source, hydropower has several benefits and is essential to the shift to sustainable energy system. Among its advantages, it is capacity to produce power on a wide scale at comparative low operational cost. Hydropower will be without challenge and obstacle though. Ecosystem disruption is one of the major environmental issues that require attention. In conclusion, even though hydropower is an important part of the mix of renewable energy source, social and environmental factors must be balanced in its development. Hydropower is more sustainable and resilient energy source for the future when negative effects are reduced with the aid of improved regulatory framework and technological advancement. To optimize the advantage of hydropower while minimizing its disadvantage, sustainable practice, environmental conservation initiatives, and community involvement are crucial.